Okay, guys, thank you for joining in. So this is just a tutorial on how to do electronics in Fusion. So this is how Autodesk now is moving towards doing electronics design instead of the old Autodesk Eagle. So they're merging into having both mechanical CAD and electrical CAD design in one workspace. So we're going to do an example today where we're going to do wireless PT100 temperature sensor. I built this for a previous project, and I just thought it was a good learning experience, and it was a very nice thing to learn. So when we're starting a new electronics design, what we need to do is, of course, have free Fusion, which is a free software if you are a hobbyist or something, and you can choose here to do an electronic design. So the first thing we're going to do here is we're going to open that. I'm just going to close the other tab here, and I'm going to make a new schematic. Okay, so then I would like to save it just to make sure that everything is fine. So I am going to save it under my FabLab. I can create a new folder called webinar, and I'll save it under here, and I'll just call it electronic design demo. Save. So by saving it under this tab up here, I now have two tabs. It actually makes sure to save it under the schematic as well. And when I'm in the future going to make a PCB design, if I save from like the main document, that's going to cascade through everything and it's going to save all the way through. So of course, going in here to the schematic designer, what we have up here is our toolbar with all the different tools that we're going to use. I'm not going to walk through them individually. I'm just going to let you know when I use something and tell you. Otherwise, I'd like to tell you that we have Diesel from the FabLab on the chat today. So I cannot see the chat right here, but he is in my headphones. So if you are having any questions, feel free to ask them in the comment field, and then he'll reach out to me if there is something that I should cover. So the first thing we should do is add a part. So if I click this button right here, I can add different things. And the first thing that I would like to add in is a frame. So if I search down here for frame, I get all the search options that has something to do with frames. So I have like the top level menus up here with the small arrows that I can close, so like the folders. And the one I know that I want to use is this one called frames. And under here, I have these frames that I can use just when I want to print something out. That's often the first thing that I would like to do when I make a schematic design. So the one that I want to use is this one where we're in landscape mode for an A4 piece of paper. So if I click OK, I'll place that at the origin, being right here down here. And when I click, it's going to sit in the schematic at that location. So you can see that I can also add in more schematics if I want to. I can add another one. I'm not going to. I'm just going to press escape, and that's going to let me go right back into my add part. So the first thing that I would like to do here is I would like to add my microprocessor. For the case that I used here, I used the ATmega, which is the one that we also have on the most Arduinos. So if I search for that, I'll get the search options here. And if I scroll down through them, you can see here on my right side that I have the schematic design and the PCB design. So this is, of course, where in the schematic designs of Fusion Electronics and as well in Eagle, you have to make sure that you choose both the right schematic and the correct PCB layout. And that's where they come in different configurations. So you can see here that I have an SMD component with a thermal pad in the middle. I can also have a through-hole one that we usually have on the Arduino Uno. And here in the bottom is the one that I use, the SMD edition of them. So if I would like to place this one, I can just click place, OK, and I can place it. I can place another one if I need to, but I will press escape instead. So, and then since this was a wireless thing, I need to add in a wireless module as well. So I used for this project what is called an NRF 24L01, it's called. But I don't want to type the whole thing. I just want to search for NRF, and I don't get any results if I do this. And when you're working in Fusion like this, you have to put in wildcards if you need it to, if you want it to return more values. So right here, I added in the wildcard. So that now search anything that starts with NRF. I could also add one in the front, and it will return everything that contains NRF. So if I just look through this, some of the things that I usually look for is this symbol right here, meaning that it also has a 3D package built into it. So you can see over here now that we have the schematic design, the PCB design, and the 3D design. So I added one in here where I have a module that I just used. I just bought a module off eBay, and I placed this on my PCB design. So if I want to add this in now, I'll just press OK. For rotating and mirroring, I have a toolbar option out over here, but you can maybe also get used to some of the shortcuts. If you do a right click, you will rotate by 90, and the middle mouse is going to mirror. So I'm going to place that here. So that is just some of the things that we are going to do in here. And the next part that I'm going to use is called a max. And this is a specific it's a specific component used for controlling these RTD PT100 sensors, which is just a resistor determined temperature resistant RTD. So it's resistant temperature determined, I think. So we're going to place that in here as well. I'm going to place it right here. And I also need a connector for that. So I went online for the project, of course, and I searched on RS online, and I found that I would like to use just the usual mini jack for this. And then that thing is called, I just found the manufacturers online, and I added that to my library. So I'm just going to search for it like this, and here I have an SMD component of a mini jack. So this is usually how I prefer to work. I place all my components first of all, and I might add in some more later on if I need to. So for power, we have, of course, a terminal for that. I can maybe show you how I would add a component to the library. I think that's actually a very good idea. So if I need to search for a specific component, because we often, for example, work with this kind of shield up here. So if I need to add that to my library, I'm just going to copy in the name here. I don't have to remember it. And if I go online and I search for that, and I still search actually when I need something for an Eagle library file. So often some of them I like is this one right here, wireless modules from DIY modules. And here I see that, okay, this schematic looks like something that looks rather nice. And the same thing goes for the PCB design. So I think I could do here is just to download a file here. I'm going to download that file. And if I go into Fusion and I would like to add this to my library, what I need to do is then to open up my library manager. So I'm just going to show you one more time. I clicked add part, and then open library manager. So right now it shows me the different libraries that I have in use in my design here. And then I have the ones that I actually have toggled on. And then I also have a few available ones. These are all the libraries that I have that I don't have in use. And if I search for something, they're not going to appear for me. But in here, you can also add one. So I have this option here for browsing. So I can browse to my download folder and add in that library. I already have it, and I actually also recommend you to do, so I have under documents on my computer, under Eagle, I have libraries, and in here, for example, I have this specific chip for controlling the PT100. So I usually prefer to put it there because I'll have to make sure that it doesn't disappear from my folders, of course. So I could add in this library. I don't know if I can do it like this. No, I can't. But just make sure that you put them somewhere that you don't delete them. Otherwise, of course, it'll disappear from the library. It will not disappear from your design, but it's going to have an error in there telling you that it cannot find the folder anymore. So that's just a quick way of doing. I'll not go over in this video how to add in 3D models. We can maybe do that in a future live stream. But for example, for the antenna module up here, I downloaded exactly this library and it did not contain a 3D model. So I added in a 3D model myself. I just went to GrabCAD, which is also a great resource for finding stuff. And when I went in here, I just searched the exact same thing. I searched for the module and I found all of these modules right here. And I added them together. But it's a little bit more complicated, and it's still a new thing that Fusion is trying to do better. So it might change actually, but it worked okay. So the next thing is that we need to connect all of these things right here. And I don't think that I will be able to connect everything up as it's supposed to be, but I will show you just some of the cool tips and tricks. So for example, I will have a terminal down here and this is going to be my power connector. So the power that I receive is changing. So I will add in a voltage regulator. And here I can find something like this, an SMD component that I will place out here. And the next thing that I would like to do then is connect them together. So then I'm going to use the net command here. So this is the command that we use to connect stuff together. It also has the key R as the shortcut. And then I'm able to connect two things together. And I have these small circles for snapping. So I'm connecting them together like that. And then I also have a ground connection. So I'm just going to, so you see how it actually is, like this is not looking pretty. So if I want to change this, what I can do is I can use my right click, and that's going to use the alternating route to do this. So if I right click, you can see how it changes between those two. And I also have the privilege of coming some part, clicking for adding in that specific place, and then go further. So if I want to lock a specific part of my route, so I can do it like this. Then one thing I would like to do is I don't want to route everything from my output over here. This is going to be a 5-volt output, and I don't want to route that all the way to the different components. I'm just going to add in a label right here for 5 volts. And I actually have that as well under parts. So if I go under here and I just search and do nothing, I get all the libraries. And I know that there is one, I think it's called power or something. So I have one here, power symbols. And don't get confused on my libraries right here because I have one local and one from library.io. Library.io is the one that ships with Fusion. I prefer using those as they stay more up to date. This is an old way of doing it in Eagle. So under here I have all the different parts for example, 5 volts plus right here. So I'm going to add in that. And I'm going to click escape. And under here, I also have the ground connection. So I have a ground right here. I'm going to add that right here. So if I click escape and just get to the default key, I can drag and I can hold now. This is the thing that they added with Fusion. And so you can see now that it created a small circle dot right here, meaning that it actually connected these two parts together. So if I delete that and just reconnect it up here, maybe it looks a little bit more pretty like this. It asks me if I want to merge these nets, that is going to merge this net command and the ground. So yes, I do want all of this net to be grounded. And Then one thing that we usually see maybe with these parts here is some of these normal passive components that we have. So under my libraries up here, I also maybe want to find a capacitor. So I have here capacitors, and I have normal capacitors, and then I just have to choose a size. So I'm going to use this kind of size of a 805. It's like you can solder this by hand, and I'm going to add one of those in, and maybe also one on the other side. And I'm just going to wire that in on here. So, and connecting this to 5 volts, it's going to prompt me, oops, do you want to merge this net with V plus? Yes, I do want to do that. Then a good thing that you might want to do is you might want to change the labels. So right now I just added in a capacitor and it doesn't have any size on it. But of course I need to know that for later when I have to order all the parts. So what I can do is I can come up here into, actually don't remember, maybe it's under modify. Yeah, modify and value, or you can just type V. So if you type V and you click on a component, it lets you add in the value for that capacitor. So I don't remember on top of my head, but this is probably something around like 100 nano. So, and then we're going to add in 10 micro. Okay. So now if I want to get a little problem with zooming like this, and now of course I need to hook that up into my my microprocessor as well. I'm just going to do quickly routing this. So I'm just going to do it like this, and I'm going to go down and grab the 5 volts. Just like so. Same for all the ground pins, going to do that. No. No. I don't know if I have problems with my connection, but I do receive you, Diesel, but I do have a hard time hearing exactly what you say. So you might need to mute YouTube while speaking to me, otherwise it'll echo in my ears. So what I just did here is I just changed the labels. Oh, grab and copy. Yes. Gotcha. So what I just do, I just used a shortcut command for it, and it says right here, it's just for my computer, it's Command C. So I can, if I just do Command C, it's going to bring up the copy command. I'm just going to click the tools here and move over, and I prefer to copy over finding the part again, because as you maybe have seen in here is, oops, just going to close my calendar. So instead of going down under power and finding the exact same thing again, I might accidentally, I can just do P for search, so it will search it. So I have many different types of ground, and I might accidentally grab a different kind of ground, which looks very similar. But if I do grab different parts of these, they are not going to be connected together. So it's very important that I remember to use the same symbols here, as they will connect together. So it knows now that the 5 volts here is connected to this 5 volts up here. And I can see actually that I just missed this VCC as well. Okay, so the next thing that I would like to do is these kind of antennas right here. This is using the protocol of SPI, which is of course data transmission. So it has this MOSI and MISO, which is also down here on the microprocessor. So first thing we need to do is maybe add ground and power. So I'm just going to add So I'm just doing the Control-C again, and I'll add them together like this. And I can just drag and hold to move it a little further down. And here comes also an important thing. So you see here that there is no dot like there is here. That's of course because we're not connecting 5 volts and ground together at this point. Otherwise it will cause a short. So the next thing that I gotta do is I gotta connect all these parts up here. And a quick little tip for doing that a bit quicker is that you can right click on your part and do breakout pins. And then I can do selected pins. And I want to break out these pins here. And I'm just holding down Command to let me check them all. And the label format, I'm just going to use the pin name. I'm going to transfer that over, pressing OK. And that's going to add in all of those labels. So when we label something together, it's the same as the 5-volt command here. So if I now do, for example, Mosi right here, I'm just going to do this manually now, how to do labeling. So again, up under, I use the shortcut so much that I forget where stuff is, but the label command right here, or the name command, they are mostly the same thing. If I, for example, click on name and I click on this wire, I'll get the option for changing the name, for example, here to Mosi, and it has this checked mark for place label. And if I do OK, I'm going to get the label, just as I have over here. When I use labels, I prefer using this type right here instead. So I get this small label on top of it, like it's getting framed. And from experience, I just know that if I change the size to 0805, it'll fit. So when I do the next one down under here, and I now press N for name, and I click on this one, and I will name this one ISO. And yes, I am going to connect them. It's of course remembering my label style, so I can place that. And now it looks rather neat that they actually fit together on top of each other like that. Otherwise it would, and they'll go on top of each other. Okay, we also need to add in this SCK being the clock. And so all of that has been labeled now. And then we need to do a pin selection as well. So I'm just going to add that to number 12. Call that CE. Just have to remember I have my schematic next to me, so I just have to double check that I actually am not telling you something weird here. Actually, this is CSN, just like so. And then I connected CE to this one. And I honestly don't remember why. I checked it up and I figured out this is how this is how it should be set up. So that's how we're going to do that with all the different labels and styles for that. And we have the same thing over here. And I'll just add in the rest of the components, and then I think we will move on to the PCB design, even though that I haven't finished the specific all the wiring. If you guys have any things you want to ask for specifically in the schematics design, just write it in the comments, and I'll try to see if I can get to it. So just for adding in the parts that I need, I'm going to find resistors, a few of those, and I also have an OLED screen that I want to add in. Going to do like that. And what else do we have? For resistors, I'm actually just going to use I'm just going to go through resistors and find one here. I'm choosing the EU symbols. And again, I'm going to choose 805 resistors. So let's see if there's a few locations that I should add those to. Pull up resistor for reset. I have also a few reference resistors over here that I need to do. And what else do we have resistors for? Let's just add. I'm checking here my schematic for seeing if I am missing something important. So this is not how you should wire it. I'm just going to wire it like this, just to make sure that I get the wiring commands over in my other schematic. Do not use this as a reference for how to wire this kind of circuit. So maybe another command that I want to show you here is so if I need to move this one right now, I can drag it like this, but I do also have a move command. So if I can either choose move or press M, and that will actually also let me move it. The difference between those two parts is if I drag one and I try to right click, I have to hold down both keys. But if I just click on it and try to move it, I can't. So that's maybe you can find it a little bit easier sometimes if you use the move command, because if I click and let go, it'll stick to my mouse until I click it once again. So that's maybe a little trick you can use if you're having some trouble with that. And we were also just going to wire in the OLED screen here. Command C and route. Going to do it one more time with the labels. So I'm going to break outputs, select pins, choose both my pins, and I want to output the pin name. So it's going to output this. This is the I2C protocol. And if I just want to do the exact same thing over here, I can find those two pins right here. So if I do route and I just click on these two pins and I name them SDA. Yes, I do want to connect that. And the same thing goes here. Pressing OK. Okay, so now I think I have an OK schematic for showing off today. So when I want to move in towards building the actual PCB, I will switch. So I'll go up here and I will switch to the PCB document. And when I do this, it's going to add another tab up here. It's going to import all the different components that I have down here. So I have them down here. Here I have the screen, the antenna, my microprocessor, the jack, the different of the passive components, terminal, and so forth. And maybe a thing I should do now is I should save. So if I save here, I just doing Command S, it'll save this folder right up here. So you'll see the check mark. But if I go again and show you out here, and I'm going to save this, it's going to save both the schematic design and the PCB design. And you can see they updated it and it figured out this is like where it's making sure that it knows that these two parts are linked. So this is like the managing page. And you have to keep them open. It's quite important in case you delete something, because if I close one of them, they are synchronized. So if I add in components into the schematic, it will update in the PCB workspace in here. So first thing, I'm going to close this off so I can show you a little bit better. And the next thing I would like to do is to make this PCB size a lot smaller. So I can just drag on the outline and I'll just make it something smaller. I'm just going to see if I can fit everything on this. I'm making it a little tiny because I want to show you a realistic thing here, and so a lot of these things are in different heights, and that's the reason why I'm doing it this way. So one of them, we could, you can also, because it's inside of Fusion, actually later on edit the outline inside of Fusion and importing it. I have tried it, but it is a little bit more difficult to actually make the PCB inside of Fusion and then pushing it inside here. I find that it's getting there, but we have a lot of crashes if you're trying to make a part and trying to link it in to a PCB design. So I will show you how you can edit the board line outline inside of Fusion a little later, and so you can get a little bit more precise what the size of your board outline should be. So first thing first, I am going to place the OLED in roughly the middle here, and I am going to place my antenna on the bottom. So for moving stuff on the bottom, I'm going to do move. So I'm going to click this. So now that I have let go, it's going to follow my mouse around, and then I'm going to mirror it. I'm going to do either going to click up here for mirror, or I'm going to do the middle mouse. And that's going to make sure now that it's on the bottom layer. And I'm then going to place that roughly here, maybe a little off the side again, just like so. And that's the major two components that I have. And then I have my terminal. I'm going to place that here in the corner. And one thing you should notice here is I get this hatched red mark, and that's meaning that I am in violation. These two holes are too close for manufacturing. So I'm just going to move my screen a little to the right, and this is actually a little too much. I want to move in finer grids. So it gives me the opportunity to show you a little bit about grids up here. So we have the grid size settings. So in here, the size is 50 mils. You also do have the option to choose metric sizes here. So, and that's just how fine you want the grid. I do prefer to work most often in mils for doing like the width of routes and so forth. So I'm just going to leave it at that for now, but you do have the option of just changing between them, and you can see that it will convert the numbers. So sometimes I need to change into millimeters for getting something metric to fit. So if I choose 10, you can see that I will have the ability to move this in a finer grid size. I'm going to place this one in here, right click again for rotate, and I am just going to put it again in the middle, and I'm going to have it so that the part of the block here is extending a little over the board, because when I do an enclosure, I want this to stick through. SMD components, they usually are on the bottom side of a PCB. So I can highlight them all and it will select them in one big group. And I then have the ability to just do the middle mouse, and you'll see here if I actually have to move them. So highlight and then move, click on them so they stick. I'm going to highlight. Like so, middle mouse, and change. You see the colors, they change. So it goes from the red colors to the blue colors. And blue colors means that it's on the bottom layer. You'll see your layer settings in here for display, and you will see that the top layer is red and the bottom layer is blue. So I just changed them all to be on the bottom layer. So now I don't have to worry too much that they collide with, for example, the jacked block that I have here on the top. So I'm just going to press and hold. So my microprocessor is roughly in the middle. Place my voltage regulator fairly close to the terminal where power is getting in. And then I am going to see if I can fit this close to the jack stick where the sensor is getting in. So I might have to move the processor. So now I actually have my screen in the way. So what I'm just going to do is I am going to turn off the top layer. So if I just turn this off, the top layer, and everything there starts with T is actually top layer. So T place being a top layer, and T origin, and T names. That's everything there is going on the top layer. And all of these things here are just the names and values there is getting written on the top. But they can be a little confusing to work with. I'm just going to move all these closer so when I zoom in, I can work with them a little easier. So now moving the microprocessor again, like so. It's going to move it so that it's here, I think is okay. And the next thing we need to talk about is all these wired lines. They're called air wires, and they show you how stuff is connected. So when I do now, especially with these passive components that we usually have a lot more of than these few ones we have right here, when I do M for move and I press on this one, it shows me in a line to where it's going to connect to. So it makes sense to place them rather close to where they're actually connected. So you can see that they should maybe be they should maybe be placed like this. Yep. So often the lines here, they of course this started out in a completely other way, and it's trying to connect them as well together. So if I want to make sure that it calculates the new closest route that it should do, I do what's called RadNest. And if I hover over this one, it's actually the same thing as this Poor Polygons. They changed names from Eagle to Fusion. So before it was RadNest, now it's Poor Polygons. If I press this, it's going to recalculate. So you see now that it actually changed a lot of the air wires to be connected in different paths. So I'm going to turn on my top layer again. I can do this also with some presets that I have down here. So I have the ability to do preset standard. And that's going to just put me back to the standard operation that I was in. So the next thing we need to do here is I often like to work with ground planes. So usually I tell Fusion that everything on the board should be ground, except if there is a wire running through it. So that's often one of the first things that I want to do because I just want to connect all the ground pins together. And the best way I find to do this is to right click on the board, and then you have this convert to polygons and then copy. It's going to ask you to which layer do you want to copy this, and I want to copy it to the top layer, and I'm going to do OK. And you see here now that I have a really thin red line. There is dotted all the way around. So if I now do Poor Polygons again, it's going to make it all red. So you see that it encapsulates all the different things. It keeps a distance from the paths, except I wanted actually to connect to this one right here. I wanted it to connect to the ground plane. So if I need to tell that that polygon should now be ground. So I can do unpoor polygons. That's going to remove it again. And if I right click on the polygon and do properties, I can in here choose the name to be ground and do OK. And yes, I do want to connect that to ground. And now you can see that there is a small cross in here. But this cross is a little, it's a little fine. I want, of course, these lines to be thicker. And I control that by unpouring the polygon again and clicking on the polygon. And I have this width right here, which is set to 0. I want it to be 10 instead. And that's the control for how thick this connection is going to be. I'm going to see if I can actually get it to do that. Right click maybe, properties, and width 10. Okay, so you see it got a lot thicker there. And when I now do pour polygons, the paths look way nicer. That's exactly how I want it. So now you can see that I have the ground pin here connected and the ground pin here. Same for this one down here. And now I want to do the same thing for the bottom layer. So I'm going to do unpour, going to hide my top layer. So I can again right click on the border. And now I'm going to right click, copy to polygons, copy, bottom layer, okay. And same thing, now I'm going to do instead of, I'm going to name it by the name command. So if I type in N, click here, I get the name command, GND for ground, right click, properties, width to 10, okay. And now if I pour, you can see that it connected this big ground pad and the ground connections for the resistors together, here, here, and here. So that removed a lot of my air wires. It removed all the air wires for ground. And that's usually a lot of the connections that you have. So we're going to show the top layer again. And now I feel like we should be ready for routing. And I'm going to hide unpour the polygons so I am able to route. Again, the command is, the shortcut key is R, but I also do have right here, manual routing. And then I get some options. I have manual routing for doing exactly as I want. I have avoid, and then I have move. So I usually prefer go around. So you can see if I now press on something, for example, this one has an air wire over here. So if I press this one and I move it over, I can connect it to this one. But you will see if I try to move it into this one, it won't. I cannot make these two things go together. So this is so if I went into manual, this is full manual, and you'll see I get the hatched bar, meaning that I have an error. And then I have the move command. You cannot move components, like it will not do that, but it will move a wire if it's in the way. So I'm just going to choose the one that I prefer the most, go walk around. My width, I'm going to change to 10, and I'm going to tap here in the middle. So now these two paths have been wired together. And I can, of course, sit here and do this all manually, but inside of Fusion, you actually also have the capability to do this with an autorouter. So it does a pretty good job. I find it often to be rather good. Of course, there needs to be some checking up, but it does a really nice job. So I'm just going to delete those two paths that I just built. And the way to do that is with the rip up command. So I have here a rip up command, and in here I have delete the section that I click on. So if I, for example, zoom in here and I click on this small section, it will only delete that part. The next part here is delete connected copper. So that will delete both this part here and the other part. So if I click on that, the same thing goes here. If I click on this, I'll delete all that. And then I have all connected copper on the same layer. And what are these for? This is the whole signal and between components. You can hover and it will tell you. But let's try out the autorouter. So I have this here called quick route. And in the bottom of this one, I have the autorouter. So the electrical design has up to 16 layers. We only have 2, so we have the top and the bottom layer. You can choose to not do anything on the top, and it'll not do anything on the top layer. So this is an option if you are doing one-sided PCBs, for example, for CNC milling or something else. But I am going to stick, as this is an SMD component and it's quite small. Yeah, I'm just going to use them both. And then I'm going to do effort. I can choose high effort. It's just going to try more options if I do high than if I choose low. And then I'm going to do continue. And I'm just going to zoom out a bit so you can actually see it working. So I'm just going to do it like this and do it one more time. Auto router, continue. And remember here to click start. Like I thought for a long time, like, is it working? But you have to remember to press start here and it will start calculating all the values. And in a little bit, you'll see that it actually tries out some of the different options. So there we go. See all the different routes that it's trying to do. And usually place the best one in the top here. So usually we go for the lowest number of vias. So this meaning connections where you're jumping from the bottom to the top layer. And this is pretty good. It reached 100%, meaning that it did manage to calculate a route for connecting everything together with only 2 vias. That's pretty good. But of course, I also don't have nearly as many signals as I usually have. I'm just going to press end job, and now it's going to put them on here. And then I can do pour polygons, and it'll remove the ground plane from the signals. So now you can see that I have a signal running in here, and I have some of the polygons are around it. So this is often the way to do it. This is a pretty quick way, and yeah. So what is the width of this track? That's often a thing. So right now, if I click on this track right here, this has the width 6. So why is it 6? That's because of the default design rules that we have made inside of Fusion. So if I press up under here on the rules DRC, I have my DRC tab in here. And this is where I configure how my board is going to be. So this is the thickness for the board. And we have clearances, how close the boards can be together. So often, if, for example, we want to mill something, we can use a small bit for that. And we can actually just type in here, I want there to be 0.1 millimeter between the different parts. And it's going to obey that. And it actually makes us able to prototype these in a place like FabLab, where we could just put it into the router. I'm going to leave everything else. And the reason why it was 6 mils is because of this minimum width that it's going to do. I'm going to change this to 10 mils. And I'm going to only change this one as well, the thermal pads, where the ground plane and the solder pads are going to be. So I'm also going to change that to the 0.1 milliliters. So I can do select, and it's going to tell me that there is a possibility for design rules, like that there is some errors in here. We're just going to do okay, that's fine. And it's going to tell me that there's a lot of errors. I'm just going to do RASNest first of all. And actually, I would like to reroute this whole PCB one more time. So I'm just going to rip up all the connections. And the way to do that is if you click on rip up and you just press OK without tapping anything, it's going to tell you, do you want to rip up all signals? Yes, yes, I do want to do that. I'm going to do pour polygons, quick route, outer router, and continue, and start. It's going to go over it one more time, and we should hopefully get something really close. And I see that we're running always a little late on time, so I am going to change into the 3D workspace here in a bit to show you how we're going to use that now. So end job, and then pour polygons, things you should usually check is that go under rules and DRC. You can do just check. Yes, that's fine. I have one error here. I have one air wire. So if I click on this, it's going to highlight, oops, that there is an error right here. It doesn't have these two pads connected. And it's two ground pads. And that's just because I have some tracks that is breaking up how I do my ground pads. It's like the ground plane. So what I usually prefer to do is I just put in a ground via. So the way to do that is to do a via. So if I press here and I also place one out here and I just rename those to being ground. So this now connects ground from the bottom and the top layer together. And I just and if let's just see here if I can find a better place. I'm pretty sure like Diesel says to me that that those two should not be able to connect because of DRC, and I'm telling him it will connect. It just has to be in correct spaces. There we go. So now these two pads have connected, and it removed the air wire. So now if I go under design rules and I have a clearance mistake, that's fine. I can take care of that. But I don't have the air wire anymore, so I can move this over, and it actually, so now I have no mistakes on my board. So that should be all good. The last thing I want to do is I want to convert this into 3D PCB. So I will just do simply click the bottom up here, and that will convert everything into a 3D design workspace. It does take a little bit of calculating time for computing. So we'll just give it that, of course. And the first thing I'm going to do after is I'm just going to save this. So be aware that the electrical workspace is a new thing in Fusion, and it does on occasion crash. So Fusion does a good job on auto-saving every minute, but just be aware that that is an issue that they have. So if I go under here, I'll save, and it should save all of the components, and it will show me that everything is linked together. I'll get the 3D design in here as well. So perfect. I did manage to get things to look okay. I have a little bit of a interference collision right here, mechanically speaking. So and I have the components on the bottom just as I wanted. So so this is fairly good. Maybe one thing that I could show you how to do is how to work with the PCB board layout inside of Fusion instead. A way you could do that is down here in your timeline. The first thing there is here is the sketch. So if I go into the sketch here, I have the option to do dimensions on this as I would usually do in Fusion. So I will do the D for dimensions. I also have the tool right here. And I can now set this to, for example, 40 millimeters. And I will make these two perpendicular. The same thing goes for these two. And then I'm going to make this one 30. Let's not do 30, let's do 35. Oops, get a little bit of issues with the, I'm just going to do more constraints on it so I get it locking just like so. And I'm not going to bother with the holes as they are determined by the screen placement. So please don't try to tie these too much down because it's getting forced back into Fusion into the electrical workspace as a mistake. So if I now do finish sketch, it will update the PCB size, and I can then do push into 2D PCB, so I can get rid of this out of sync mistake. and then I can do pour polygons again, and it's going to make sure that the size, I can change the size of this to be more fitting. Like, or I could delete them and do them one more time. That would actually maybe be more correct to do that. But I just wanted to quickly show you that that is how you would edit the layout inside Fusion instead of doing it inside of the electronic workspace. Maybe a few other things that a pretty cool other trick is I told you that I had a little bit of interference between my terminal and my screen. I do have the ability to fix that inside of the mechanical workspace. So what I can do here is I can do a move command. It'll just have to compute. And if I then I can just press move and press on this component, and I can move it to the side a little bit. And if I do update PCB and reroute, it is going to try to calculate the new. So you see still here that the holes are not aligned. But if I do both update PCB and reroute, it is going to try. And this takes a little bit of compute time as well to reattach those things. And I think it's going to successfully do this because we have so few wires. But I wouldn't always recommend you to do the rewire inside of Fusion here, because it might cause a lot of mistakes inside the electrical workspace. It does also cause a little bit of mistakes here. I see on the holes here. I think if I, yeah, I've seen this mistake once before, and you'll have to delete. There is a extra hole here that it doesn't like, and I can just highlight and delete it. It doesn't do anything. It's a small mistake that they have. For now, hopefully they will fix it soon. It is still a quite early thing, but I am quite excited to see a company trying to move and merge this mechanical and electrical workspace into one, so that I have the availability to only work in one program like this. And even though that I find mistakes for my mechanical model where I run into interferences, I have the ability to quickly jump into my electrical workspace and update and then just move it a bit if it fits better for my mechanical parts, the different places. So a way that you would usually take this design and move it into another design is just to make a new tab, save it, and call this, let's just call it mech example. And then what I can do here is I can, under FabLab folder that I have and the webinar, we here have the design. If I right click and insert into current design, I'll get a linked model now of my whole electronic thing here, and I can then build my mechanical component around this. So I get something there is truly connected together, and I can reference off this and rotate and move it and use the geometry to make sure that my whole alignment, everything is in the correct place. So that's just some of the things there's like really cool in some of this. Questions are a good time now. Otherwise, I will finish off with one last thing on my list here, and it's not really very important, but I just think it's a rather cool thing that people maybe want to know. Is under manufacturing. Here you have the CAM processor. This is where you export Gerber files. Perfect. So exporting was one of the things, and this is how I do it. CAM processor is how you export your Gerber files for getting this done somewhere in China or elsewhere. and it defaults to a template for 2-layer, and you can see under here that it just makes the Gerber files you can use for either putting it into ACID and making them, or manufacture them that way. So this is where you would export, and I would usually choose export as zip, and I can just use process job and save it somewhere on my desktop, for example. So that makes all my Gerber files. I also have the ability to change the color of the PCB design if I wish to. So I can do board. Nah, it's not in here. I think this is not. Oh, there it is. So here in here I can change to. Is it? So if I don't want a green board, I had a black board in my design, so I can choose a black board instead. And if I export this now into Fusion, I'll get a black board instead. And the last thing maybe is what I find most very useful in here is that now that I have this part in Fusion, we have the ability to go up here and either do a render, so I can do a more photorealistic picture of my PCB design. If I wish to have it in a report or I want to show it off to a customer or something, I can do a render of it. But more importantly is that I have my manufacturing workspace in here, so I can directly do a CNC of the PCB here in the middle. And that's one of the things that I'm thinking about doing a future live stream on, is how do we import these PCB designs inside of Fusion, and then how do we the best way build it so that it's easily built from a CNC router, so we can easily and rapidly prototype through our boards. That's some of the things that I am very excited about. Otherwise, I will finish off and say thank you guys for watching. It's been a pleasure.